Hi, my name is Paige Nato, and today I'm going to be talking to you about lipids, more specifically the chemical structure and the different types of lipids that there are. Now, all three of these that I have right here are different types of lipids. This is olive oil, this is shortening, and this is butter. Now, lipids are simply molecules that contain a lot of hydrocarbons and that help the body store energy. One of the most common types of lipids are triglycerides. Triglycerides are simply glycerol attached to 3 fatty acid chains. So basically what a glycerol looks like is this. This is what a glycerol were to look like. Ignore the pink. It's the only color I had to draw with. But this is what a glycerol looks like, and a glycerol only becomes a triglyceride once you add fatty acids onto them, specifically 3 fatty acids, which is why it's a triglyceride. Now a single fatty acid looks very similar to this. This is what a fatty acid would look like. So, like I said before, when you add 3 fatty acids to 1 glycerol, you get a triglyceride. And this is what a triglyceride would look like. Now, the chemical structure can vary between them. There can be more carbons, less carbons, but basically overall, this is what a triglyceride would look like. There are more than one type of lipids that exist. As you can tell from here, these are all different lipids. There are unsaturated lipids and there are saturated lipids. Saturated lipids are solid at room temperature, and that is because they are carbons. They are a chemical compound that has carbon saturated or completely filled with hydrogens. As you can see here, butter is the most saturated. I'm squeezing it. It is hard. Whereas oil is the most unsaturated. It's liquid, going around. The main difference between saturated and unsaturated lipids is the chemical structure, like I said before. The biggest difference between a saturated lipid and an unsaturated lipid is that an unsaturated lipid has at least one double bond on its chemical structure. Now, like I showed you before, this is what a saturated fat or lipid would look like. And this is an example of the chemical structure that would be a saturated fat. As you can see, there's as many hydrogens as can fit onto the carbons, and there are no double bonds. They're all single bonds. In contrast, this is what a unsaturated fat would look like, and this is an example of what the chemical structure would be. Now, an unsaturated fat can have more than one. If it has more than 2 double bonds, then it is considered a polyunsaturated fat. So this example that I have here and was showing you here is also an example of a polyunsaturated fat. Now, most of the time, if you want to figure out the difference between the levels of saturation, I guess what you can call it, is there's a table that you can do. Now, butter is the most saturated that I have with me right now. Butter is about 60%, or maybe a little more, a little less, saturated fat, and has a little more than 20% unsaturated fat. Whereas Crisco here, as you can see, it's a little more pliable. I can kind of play with it a little bit more. This is only 30% unsaturated fat, or saturated fat. I'm sorry. Now, in complete and total contrast from this two, this is olive oil, and olive oil has between 74 and 75% unsaturated fat, which is why it is so much more, it's completely and totally liquid at room temperature. Most of the time, vegetable oils are made up of triglycerides, as well as other chemical compounds. Vegetables overall have a much lower saturated fat content than animal fat, as you can tell from the oils, and animal fats are a lot more solid at room temperature. In unsaturated lipids, they are usually classified as polar lipids, meaning that they have a hydrophobic head that is attracted to water, and a lipophilic tail, which is attracted to oil. So here, if you look at this substance, this is a substance that I have already made, and this is olive oil and water. And if you look really closely, you can see that there's almost like a membrane formed around what would have connected the two of them. And this is the polar substance that makes lipids the way that they are. Now, in contrast, nonpolar lipids are hydrophobic against water. They repel water, and they are usually they're very resilient against water. Most cholesterol that we have in our body or that we can find are considered nonpolar. Now, if you wanted to make an unsaturated fat more saturated or make a liquid more solid, then you would have to go through a process called hydrogenation, which is basically the process of adding more hydrogens to unsaturated fat, making a liquid more solid. Now, the biggest problem with hydrogenation is that trans fat can form as a result of the hydrogenation process. Trans fats can be found in a lot of fast food and processed foods, and they are very, very unhealthy for you. They damage your body because they increase your bad cholesterol levels, which are known as LDL, and they also reduce your good necessary cholesterol that keeps you healthy, keeps your immune system strong, and that is known as HDL. So, overall, there are a lot of different types of lipids, even more than I have here. There's more than just olive oil. There's vegetable oil, coconut oil, tons of different oils. There's a ton of different fats. There's margarine, which is man-made fat, as well as different animal fats that you can use. And shortening is just, hydrogenated vegetable oil. Basically, the biggest thing that you want to do when you're distinguishing lipids from one another is to figure out which has the best health benefits for you, depending on what you're making, depending on what you're using it for, as well as knowing the specific task, because each one has their own chemical structure as well as their own specific task for you. And the biggest thing is to figure out which one fits best. So, thank you very, very much. And that is lipids.